So what is the first property? The first property says that the joint probability density function will be always positive. Okay, it is non-negative. Probability density function is non-negative number. Okay, so we'll see the proof. So what is joint density function? Fxy of x comma y is nothing but the second derivative of the joint distribution function. Okay, so it is dou square fxy of x comma y dou x dou y. Okay, and we know that what is fx comma y of x comma y, that is joint distribution function. It is the probability of x less than or equal to x and y less than or equal to y. So what is the formula for distribution function ma? It is the probability of getting x less than or equal to x, probability of getting y is less than or equal to y. So the joint occurrence of this. The joint means what? The joint means intersection. So it is the probability of x less than or equal to x intersection probability of y less than or equal to y. Okay, and we know that the probability of any event will be non-negative number. Okay, probability of any event will be non-negative number. So the joint distribution function is also non-negative. Okay, since it is non-negative, the derivative will also be non-negative. The derivative of that will also non-negative. From that we can say that the joint density function is non-negative number. Okay, and what is next property says? The second property says that the area under, see here, the area under the density function will be always equal to 1. Okay, the area under the density function will be always equal to 1. Okay, that is our second property. So what is that? Integral minus infinity to plus infinity, integral minus infinity to plus infinity f of x comma y of x comma y dx dy. What is this gives? It gives the sum of all joint probabilities for the random variable. Okay, so it gives us what? The sum of all joint probabilities for random variable x and y in the sample space. So from the axioms we know that what is the sum of random variables is equal to 1, yes or no? So sum of probability of random variables will be equal to 1. So that is why integral minus infinity to plus infinity, integral minus infinity to plus infinity fxy of x comma y dx dy will be always equal to 1. Okay, and the third property says that, okay, what is third property? The third property says that distribution function is nothing but the integral of density function. What is distribution function? It is integral of density function. That is our third property. Okay, from the definition of density function, probability density function, what is the definition of probability density function? Probability density function is second derivative of distribution function. Now what is distribution function? Now what is that we are doing? We are integrating both sides of this equation from minus infinity to x, minus infinity to y with respect to x and y. Okay, so it is integral minus infinity to y minus infinity to x fxy of x comma y dx dy. We are integrating both sides of this equation. Okay, so what happens here? We will be having fxy of x comma y. So what is this? So it is nothing but, what is this? Is nothing but joint probability distribution function. Okay, so the joint probability distribution function is the second two integrals we are taking, one integral with respect to x, the other integral with respect to y, where the limits are minus infinity to x, the y limits are minus infinity to y. Then integral of this density function will give us what? Distribution function. Okay, and the fourth property says that if you want to find the probability of joint occurrence of any event, okay, using probability density function. Okay, so what is that we have to do here? Say for example the joint event is defined like this. So x value is varying between x1 to x2, whereas y value is varying between y1 to y2. So we have to obtain what is the probability of joint occurrence of this event, x1 less than x less than or equal to x2 and y1 less than y less than or equal to y2. Okay, and what is that here we have considered? the x value, the x1 value will be always less than x2. X1 value will be always less than x2. Similarly, y1 value will be always less than or equal to y2. Okay, x1 value is always less than or equal to x2, and y1 is always less than or equal to y2. Then probability of x1 less than x less than or equal to x2. Probability of x1 less than x less than or equal to x2 is equal to what? It is probability of x less than or equal to x2 minus probability of x less than or equal to x1. Yes or no? Since what is x1 here? X1 is less than x2. How do you find out the probability between x1 and x2? We have to find out what is the probability corresponding to x2 minus the probability corresponding to x1, so that we get this range x1 to x2. So this range we will be getting. Okay, so probability of x1 less than x less than or equal to x2 is what? Probability of x less than or equal to x2 minus probability of x less than or equal to x1, so that we get what is the probability between x1 and x2. Similarly here, y1 is considered like this. Okay, less than y2. Y1 is less than y2. How do you write the probability of this? The probability of y2 minus probability of y1. It gives us what? It gives us the probability between y1 and y2. Yes or no? So probability of y1 less than y less than or equal to y2 will be equal to what? Probability of y less than or equal to y2 minus probability of y less than or equal to y1. Okay, like that we'll be obtaining. Now what is that we are interested? We are interested with the probability of joint event. What is joint event here, ma? The joint event is both x and y. What is x range? X range is between x1 and x2. Y range is between y1 and y2. Okay, just now we have discussed that joint probability means what? Intersection of these two. Yes or no? Probability of occurring this, intersection probability of occurring this. Okay, so just now we have discussed that what is the probability of occurring this event. This event is given as probability of x less than or equal to x2 minus probability of x less than or equal to x1. Okay, similarly, how do you obtain probability of occurrence of y1 less than y less than or equal to y2? It is probability of y less than or equal to y2 minus probability of y less than or equal to y1. The same thing we have discussed here, yes or no? The same thing here. In this equation, whatever we got, the same thing we have substitute. We are just substituting in this equation. Okay. So is it clear here? Any doubts here? So we'll be substituting like this. Okay, so this can be written as, so now we take, see here, we can combine these two. If you combine these two, what you get here? Y less than or equal to y2 minus y less than or equal to y1. We are taking this probability outside, so x less than or equal to x2 intersection y less than or equal to y2 minus y less than or equal to y1. We are just combining this. Okay, now this minus sign, no, whatever we are getting, that we are getting for y here. So it is minus y less than or equal to y1. Okay, y less than or equal to y2 minus y less than or equal to y1. Similarly here we have minus, no, so this minus we have considered here. Then probability of x less than or equal to x1, x less than or equal to x1, intersection we have here, no, intersection, same intersection here. Then we have combined these two. If you combine these two, how do you write? The same thing here, whatever we have written, we are writing here. Y less than or equal to y2 minus y less than or equal to y1. Okay, like that we will be writing here. Okay, so then we write it separately, each and every term. Now what is this? The probability of x2. X2 means what is the range of x less than or equal to x2 means what? It is integral minus infinity to x2. Okay, then y less than or equal to y2 means what? Integral minus infinity to y2. And what is here? It is nothing but the joint density function, that is fxy of x comma y dy. Okay, here what is the range? It is minus here, so that is why we are getting minus here. and the y range is minus infinity to y1, minus infinity to y1, and fxy of x comma y dy, okay, and dx. And similarly here, what is the x range? X range is minus infinity to x1, it is minus infinity to x1, and for this first term is minus infinity to y2, minus infinity to y2, and the joint density function fxy of x comma y dy, and what is here, the y limits will be again minus infinity to y1. So that minus sign we are getting here because of this minus here. Here we have minus, no? That is why we are getting this minus sign here. So it is minus infinity to y1 fxy of x comma y dy dx. Okay. So now we combine these two, one y1 is less than y2, no? So if you combine these two, what is the limits we get? We get the limits as y1 to y2, the limits as y1 to y2 fxy of x comma y dy dx. Similarly, and we also combine these two terms. If you combine these two terms, we get a single term with the limits y1 to y2 fxy of x comma y dy dx. Okay. So now you observe this term is common in both these integrals. This term is common in both the integral. So we can combine these two in these two terms. Now if you combine these two terms, what are the limits of x? X limits are x1 to x2. The limits are x1 to x2 because x1 will be always less than x2. So the limits are integral x1 to x2 integral y1 to y2 fxy of x comma y dy dx. Okay, so using this property we can find out what is the probability of joint event. Okay, so that is probability of x1 less than x less than or equal to x2, y1 less than y less than or equal to y2 will be equal to integral x1 to x2 integral y1 to y2 fxy of x comma y dy dx. Okay. Now we'll see the fifth property. The fifth property says that how to find out marginal distribution functions. So we know that what is marginal distribution function? Fx of x is equal to fx x fx comma y x comma infinity. What is y term here? Y term will be equal to infinity. And we also know what is the relation here? The density function and distribution function. The distribution function is double integral of density function. Now what are the y limits here, ma? The y value is infinity, no? So to find out fx of x, the y limits are minus infinity to plus infinity, whereas the x limits are same. The x limits are minus infinity to x fxy of x comma y dy dx. Okay. Similarly, to find fy of y, what is x value will be equal to infinity. So what are the x limits? X limits are minus infinity to plus infinity. Okay, minus infinity to y fxy of x comma y dx dy. Okay, so this is our fifth property. And sixth property will give us how to find out the density function. So we know that what is distribution function? The distribution function fx of x, that is marginal distribution function, is integral minus infinity to plus x, and y value is minus infinity to plus infinity fxy of x comma y dx dy. Okay. Now we know that what is our marginal density function. Marginal density function is nothing but derivative of distribution function. Okay, what is distribution function, ma'am? Just now we have discussed, no? What are the limits here? Minus infinity to x, minus infinity to plus infinity fxy of x comma y dy dx. Okay, and similarly, okay, and we know that uh, so from the sixth property, we know that fx of x is equal to what? Fx of x is equal to minus infinity to plus infinity fxy of x comma y dy. Okay. So therefore, what is fx of x? Fx of x is derivative of f of x comma infinity by dou x. Okay. Similarly, fy of y is equal to what? Derivative of fy of y dy. Okay, so this is the sixth property.